Okay, let's solve this problem. It says a ball is thrown vertically upward from the ground. The initial velocity of 5 meters per second. What is the total time spent by the ball in the air? Okay, what this means is that a ball is projected vertically upward and the body returns. Okay, now this is the height as attained by the ball. Now what you have to know is that if you project, it's projected with a velocity u equals 15 meters per second. Okay, now this velocity will continually, because it's working against gravity and air resistance, so the velocity will gradually decrease and becomes zero at this point. So v will be zero. This is the reason it has to return. If the velocity doesn't become zero, it will continually move. It will move and perhaps leave the earth, gravitational field. But because the velocity reduces from a maximum of 50 to a minimum of 0, so it will just move. Once you launch it, its velocity is maximum at the point of launching, and it will progressively decrease and becomes 0 at maximum height. Okay, so when you project a body vertically upward, its final velocity, as I have explained, is 0. Initial velocity is the velocity with which it was projected. So this is 15 meters per second. Okay, now because it's working against gravity, moving against the Earth's gravitational field, or gravitational field intensity of the Earth. So G has to be negative. If it is dropped from a height and is falling towards the center of the Earth, G is positive. But as it's moving against gravity, G will be negative 10 meters per second squared. Now, say we calculate the time. Okay, note the time taken for the body to move from this point to this point. If it is t, it will be approximately the same time it will take to move from this point to this point. So total time taken, total time will be equal to 2t, that t plus t, or 2 times t. Okay. Now we've listed out the parameters. There are 5 parameters in kinetics: initial velocity, final velocity or final speed, acceleration, initial velocity, initial speed, time, and displacement or distance. Now there are basically four equations of motion. You see, v equals to u plus at, v squared equals to u squared plus 2s, s equals to ut plus half at squared. Then distance is average speed. If you add them and divide by 2, multiply by time. Now you can see this equation, each of these equations is lacking a parameter. V lacks s in it. So when you're given a problem and it does not contain x, you use this. Okay? So if you're given an equation, this one lacks t, there's no time in the equation. So when you're given a question to answer, or a problem to solve, and you listed the parameters, t is not there, this is the appropriate one to use. This does not contain v. For the same reason, you use v if the parameters don't contain v. And this does not contain a. Okay? Now, but this is motion under gravity. So a linear acceleration changes to the gravitational field intensity of the Earth, which is gt. This is acceleration due to gravity. So v squared becomes u squared plus 2gs. S equals to ut plus half gt squared. And of course, this last one remains what it is. Now, so having listed this, in the parameter we listed out, s is not there. So the equation that doesn't have s is this first one. Okay? So the appropriate equation to use is v equals to u plus gt. So v, which is 0, equals to u, which is 50, g is negative 10, and t. So we have 10t equals 50. T is 50 over 10, which is 5. Now it takes it 5 seconds to move from this point to this point. It has to take it again under 5 seconds. So total time will be 5 times 2, which is 10 seconds, sorry.